All right, hello students. So now as we move on to Module 5, we're going to talk about areas of different shapes. So here's Lesson 1, the area of a parallelogram through rectangular facts. So we're going to kind of talk about the area of a parallelogram, discussing it in relation to the area of a rectangle because they are very similar. First of all, we're going to kind of just simply go over kind of the different shapes that either we should know or that we're going to go over. So let's go ahead and take a look at these. Look at this one. This is a three-sided shape, which is a triangle, but it's a very specific type of triangle because of this right angle here. It's called a right triangle. So let's go ahead and label them simply underneath it. Let's go ahead and put right triangle. There you go. Moving on to this little shape here in the middle. This is known as a parallelogram. This is kind of the one we're going to be discussing today. So let's go ahead and on top, either on top or on bottom, it's up to you. Let's go ahead and put into it parallelogram. I know it's a parallelogram because a parallelogram has two sets of parallel sides. So this is parallel and this is parallel. And these two slanted ones are parallel, which means they're never going to touch. Parallel simply means they're never going to touch each other. The next one over here, this is a triangle once again. It's very specific. It's also a specific type of triangle. It's not a right triangle like this one because it's a right angle. This is known as an acute triangle. An acute triangle means all the angles are under 90 degrees. None of them are equal to or greater than 90 degrees. These are all less than 90 degrees. This shape right over here, hopefully you recognize this. This is known as a rectangle. It's a very specific type of parallelogram because all these angles right here are 90 degrees. So there you go. That is called a rectangle. And this last shape over here, this is known as a trapezoid. Trapezoid only has exactly one set of parallel sides. So this is parallel and this is parallel. These ones are not, even though they don't touch on the shape. If we keep drawing them forever and ever, sooner or later they will cross each other. So this is once again known as a trapezoid. We're going to kind of talk about this trapezoid kind of later on in this section, but yeah, these are kind of the angles we're going to be, or shapes, we're going to be discussing throughout Module 5. All right, so if we kind of look down at the next exercise or activity, this part over here, the area of a parallelogram, is not on your page, but we're going to kind of use this over here to help us with kind of the next section. So in this space next to either one or another space provided, maybe even on the other page, please go ahead and write this in, area of a parallelogram. We're going to talk about how we find the area of a parallelogram. And then go ahead and draw this parallelogram in there, please. Go ahead and take a moment if you need to pause the video. All right, if hopefully you should have this part filled in now. Let's go ahead and look back. If we look at a parallelogram right here and a rectangle, they are very, very similar to each other. They both have two sets of parallel sides. These on a rectangle, these two sides are parallel and the top and bottom are parallel. On a parallelogram, the slanted sides here are parallel and the top and bottom are parallel. The only difference between these two really is a rectangle has 90-degree angles here. All of these angles right here are 90 degrees. You remember this little box here means 90 degrees. On a parallelogram, that's not true. There are no 90-degree angles. Only thing that's different is a parallelogram really is just a slanted rectangle. Well, to find the area of a parallelogram, we need to know two things. Well, the formula for, let's go and kind of go over the formula. The area of a parallelogram, or area, is equal to the base of it times the height. This is very similar to the length and width of a rectangle. Remember, area of a rectangle is length and width. Well, the base, or the B, is this portion right here. It kind of is one of the parallel sides. So right here, this is the base, or the B. And the height, well, if we look, kind of go back to the rectangle, a rectangle's length times width, we need this 90-degree angle right here. Well, there is no 90-degree angle at the parallelogram, so we kind of have to create it. The 90-degree angle is just simply a straight line from the base to its opposite. So we want a straight line kind of from here all the way up to the opposite right here. This is our 90-degree angle, and this is known as the height. So how high it is, pretty much from one parallel side to the other, This is known as the height, and this has to be a 90-degree angle. This right here is always what we're looking for. The rectangle and the square, which we're kind of used to, they already have the 90-degree angle. We don't have to find it. It's already there. With the parallelogram, we have to find this 90-degree angle. Very, very important. And then we just multiply the base and the height. And this 90-degree angle connects the two together. We're not concerned about these sides over here. We just want these two numbers, and we can multiply them together. All right, so let's go ahead and take a look at problem A. All right, so if we take what we just kind of discussed, we find the base, so we want to find the 90-degree angle, and of course it's right here. The base is connected with the 90-degree angle, so it's 6m, or 6 centimeters, excuse me, is the base. The height right here is the 4. So I'm just going to go ahead and label this h. So we take our formula, the area equals the base times the height, and now all we got to do is just simply plug them in. Area equals, well, the base in this case is 6 centimeters, so 6 centimeters, times the height, which is 4 centimeters. I'll try to slow down and make it a little bit nicer looking. And now we just do the multiplication. The area equals 6 times 4 is 24. And because we're finding the area, we have to multiply the centimeters together. Centimeters times centimeters is centimeters squared. And so there you go. As you can see, very similar to find the area of a rectangle or a square. We just simply have to find this 90-degree angle right here. As I said, very, very important. All right, so that's kind of the very basics of what we're going to be doing today. Just kind of wanted to give you the brief introduction to it. And now we're going to go into some more exercises and more activities. So go ahead and stop the video and go and move on to video number 2.